Okay, so what we're going to talk about in 7.8 is the recursive formulas. But I think what we need to do is we need to go back and talk about the explicit formulas. They call them the explicit and recursive formulas for arithmetic and geometric. Explicit formulas are the ones that will give us an answer we are looking for right away. So what you did yesterday with geometric was the explicit formula. That one, I'm hoping you guys remember, and that was a sub n equals a sub 1 times, we'll put this in parentheses, r to the n minus 1. Right? I think that's what it was, n minus 1. So that's what we did yesterday. Remember, r was the common ratio, which meant you take the number after and divide it by the number before, and that should be consistent on all of your numbers in your sequence. Arithmetic we talked about yesterday was adding or subtracting to get to that next number. So you would take your second number and subtract the number before it, and so on down the line, and that will be the same. That will be a common difference. And so a sub n here is equal to a sub 1 plus n minus 1 d. This is how you would find or use the explicit formula. Remember, where n is the term we're looking for, a sub 1, again, is the first term, and d here is the common difference. That's not generally the way we look at that equation or the way we're going to see it, so we're going to have to get used to that. So, let's talk about the recursive formulas. The recursive formulas are not straightforward. The recursive formulas build upon the term before it. So if I said, hey, we're going by 2's, then you start at, say, whatever number it is. So let's start at 3. You would say 3, and then you would say 5, and then you would say 7, and then you say 9, and 11, right? Because what are we doing? We're adding 2 to the number before it. That's recursive. Whereas explicit would be, I want the 10th term, I'm going to plug it into the 10 in for n, and it'll give me the 10th term. But if I don't give you the formula, you have to build it. You would have to start off with 5 or whatever we're going, 5, and then we go to 7, then we go to 9, then we go to 11, and keep counting until you get to the 10th term, right? So recursive takes a long time, but here is the formula for recursive. It starts off with you having to actually list what's the first term, because you can't start a recursive formula without the first term. So you start the first term, you put a comma, and then you put a sub n equals a sub n minus 1 plus d, where n is greater than or equal to 1. You have to have the a sub 1 equals something, and all the way on the far side, actually, I do believe we can, not equal to, sorry. It's just n is greater than 1, because you can't be 1. Your first term will be given to you, because it's part of the formula. And where a sub n minus 1 is the term before a sub n. So, pointer out here. This term, a sub n minus 1, is the term right before a sub n. And what you're going to do is add that difference to it. Like 5 to 7. 5 was before 7. But when I added the 2, I got the 7. Okay? So this one, if I wanted to find the 10th term, I need to know what the 9th term is. But to know the 9th term, I need to know the 8th term, then the 7th term, and all the way back down to the first term, which would have to be given to me. So if it asks for the 100th term, which formula do you want to use? Explicit or recursive?
Explicit.
Explicit, because you do not want to find 100 terms. You want to find one term. Okay? Same thing applies for the geometric recursive. Geometric recursive, you still have to state your first term. you put a comma, you put a sub n, and this one, instead of adding the difference, you take it and you take the a n minus 1 times r, where n is greater than 1. So I take the term before it and I just multiply that common ratio. If I'm multiplying by 5, then I take the term before it, multiply it by 5, and then get that number, multiply by 5 again to get the next number, and so on and so on and so on. That's how these formulas work. And the really cool thing about it is that if I'm given the explicit for arithmetic, I can switch it to recursive and vice versa, because they're made up of the same thing. They're made up of the first term. They're made up of the difference. First term, difference. It's the only things. Those are the keys to these equations. Find the first 5 terms of the sequence in which a sub 1 is 7, and you have this formula, a sub n equals 3 times a sub n minus 1 minus 12, if n is greater than or equal to 2. So basically you're starting at 2 and going up. You got the first term, so it wants the first 5 terms.
Stop it, oh my god, he cut his finger.
7, so your first term is already a 7. We just need to find the rest of them. And all you have to do, guys, is use the formula. You use the formula that you have there. We know this is a recursive formula because of this. It's a sub n minus 1. That means it's always going to talk about the term before it. And so, if I'm looking for a2, I have to go down here, and I'll put a2. a2, guys, is 3 times a of 2 minus 1 minus 12. This is how I have to write these out. Notice that I subbed in 2 for n, because that's what I'm looking for, the second term. And 2 minus 1, though, is what? What's 2 minus 1? It's 1. So now it becomes 3 times a1 minus 12. We know what a1 is. What's a1? 7. So it's 3 times 7 minus 12. What's 3 times 7?
3 times 7 is 21.
21 minus 12?
Is 8,
9, right? All that work just to find out it was 9. You have to do the same thing for A3.
So, are we going to get like 12 problems that we have to do all this on?
This is, you're only going to have maybe 1 or 2 of these, and then you're going to have to do switching between the formulas and stuff like that. Okay? Next one is 3 times a of 3 minus 1 minus 12, right? Because now I'm putting in 3 for n, which is 3 times a2 minus 12. You know what a2 is. What's a2?
9.
Yes, it's 9. What's 3 times 9?
3 times 7 is 27.
27 minus 12?
Is 15.
15. So now we found the first 3 terms. You do it 2 more times. I'm going to pause the video so it's not that long. So we found the next 2 numbers to be 33 and 87, following the exact same procedure.
In my mind.
This one is, we need to write the actual recursive formulas. To write the recursive formulas, you need to know, is this a geometric or is this an arithmetic sequence? That's number 1. Then, you need to know what A1 is, and then you'll need to find the common difference if it's arithmetic, or common ratio if it's geometric. So, how do we find out if it's arithmetic or geometric? You start to build your little caret things here, and you need to figure out, is it going, in this case, you know it's going down. So, is it going down by a consistent number, or is it being divided to get smaller, or multiplied to get a smaller fraction? And so, what's your inclination here? Is it subtracting?
Subtracting.
Okay, we're thinking subtracting. How can we tell? If it's a common difference, I'll do 13 minus 17. I'm going to do 9 minus 13, and I'm going to do 5 minus 9. You notice that's the second number minus the number right before it. Right? The number right before it. You have to do that every single time. All three of those better be the same. If it is, that means it's arithmetic. We're subtracting. Or adding a negative 4. Or a negative number. Well, it is what? Not 4, but
Negative 4.
it is negative 4. So this number here, guys, is D. It's a common difference. You're subtracting. It's the common. So therefore, we know that this is, it's arithmetic. And if it's arithmetic, we go back to our first slide and we say, okay, it's arithmetic. I want recursive. There it is. I need that formula. And that formula was a sub 1 equals something, where a sub n equals a sub n minus 1 plus d, where n is greater than... I'm going to change this, guys. I liked it when that example had n is greater than or equal to 2. So I want you guys to go back to this box here, and I want you to change both of those n numbers to 2's. And make it equal to. I like that better. Because we're talking about whole numbers. N has always got to be a whole number. It's got to be a 1, 2, 3, 4, 5, 6, okay? So, we come back to this problem. Do you know A1? Do you know the first term? What's the first term? How are you getting 4? 4 is not even up there.
13.
4 is not even up there.
The first number is?
13.
What's the first number in the sequence?
17.
17. So a sub 1 equals 17. Where a sub n, which we don't know yet, we also really don't know what a sub n minus 1 is, but what's d?
4. Negative 4.
It's negative 4. So instead of being plus a negative 4, I'll just say it's minus 4, where n is greater than or equal to 2. You are done.
Cool.
Cool beans.
Okay, guys, the next sequence, got to do the same thing. Is this geometric or is this arithmetic?
Arithmetic.
Geo.
I think it's also geometric. It seems like it's getting larger pretty fast, right?
6.
So what we're going to do here, when we build our little carrots, we're going to have to write the ratio. It's always the second number divided by the number before it. And what do we find when we divide these? What is 24 divided by 6? 4. What's 96 divided by 24?
507.
4. What's 384 divided by 96? 4. That's the same. This is R. It's a common ratio. So therefore, this is geometric. So you go back to geometric box, recursive, there it is. Notice that the only difference between these two equations is plus R or multiplied by, or plus D or multiplied by R. And so, I need to know a sub 1 is something where a sub n equals a sub n minus 1 times R, where n is greater than or equal to 2.
Yep.
Yep.
So fill it in. What's the first term now?
6.
So a1 equals 6, where a sub n equals a sub n minus 1 times... What's R?
4.
4, where n is greater than or equal to 2. Now technically, we could put the 4 in front of a sub n, so sometimes you will see it this way. Okay? In the middle. Which I think for most of us, we always like to put our coefficient out front, so it would make more sense on this one. Okay, write the recursive formula, write the recursive formula for, I forgot formula, for that sequence, for this formula. Now guys, this formula is the is the explicit formula. This one actually is the explicit formula for arithmetic, I do believe. And so, what we need to do then, and it really doesn't matter, I guess, we'll find out, for arithmetic sequence, what you're going to find here is, if I want the recursive formula, that means it has to be a sub 1 equals, where a sub n equals a sub n minus 1 plus d, where n is greater than or equal to 2, right? I just need those information. What do I need? I need an a sub 1, and I need to know what d is. Well, here's the thing. If I want to know the first term, what can I put in for n? N stands for the term you're looking for. So if I want to know the first term, I put in what for n? I put in 1. So a sub 1 is 6 times 1 plus 3, which is what?
9.
It's 9. Also, really cool thing here. Really cool. This number that's on your variable n is the common difference. That number there of 6 is your common difference. And so therefore, you know d and you know a. So a sub 1 equals 9, where a sub n equals a sub n minus 1 plus 6, where n is greater than or equal to 2. You're done. It can be that easy. Because every formula has the information there. You just need to pull it out and use it.